the tutorial sheet for week 9, which is this one, right? So there, as you can see, there are 7 questions. So I'll start with question 7 and work backwards. And any questions you guys, any questions you guys have, please use the chat room. Okay, as usual. All right. So let me change the camera. You may not be able to see this clearly, but I suggest you look at the PDF file on the course website, which is much clearer to look at than this one. Right. So let me start with question 7. Right? Question 7 has 4 different parts, right? The first part of question 7 is asking you to express. So you got this variable y, which is expressed as a times x plus b, where a and b are constants, x is a random variable, so is y. Now the question here is to find the mean of the variable y in terms of the mean of the variable x, right? So this is gonna be, okay, let's start with the mean of, this is the mean of y, which is the expectation of a x plus b. And this is a times the expectation of x plus b, right? And we denote the expectation of x by mu x. So this becomes this, right? Okay, and similarly, we are also going to look at the variance of y, which is denoted by this, right? The internet is not stable, so if you cannot hear me, please let me know. Can you hear me, guys? If you cannot hear me, please let me know, okay? So this is the variance of y, which is the variance of ax plus b. And this is the same as a squared times the variance of x, right? Because b doesn't have any role in the variance, as you know. The screen keeps freezing. Let me try. Let me try this again. Just a minute. Can you see me now? Is it better now, Millie? So this is a squared times the variance of x. So this is the relationship between the variance of y and the variance of x. And this is the relationship between the mean of y and the mean of x. So that's the first part of question 7. Okay, now let's move to the second part. The second part of question 7 is asking you to express the mean of y, the sample mean of y, right, in terms of the sample mean of x, right? Now in part 1, we looked at the population mean. So here we are looking at the sample mean, right, which is right, this is the sample mean of y, and this is equal to 1 over n times the sum of axi plus b, right? And this is, if you take the sum inside, you will get a times the sum of xi plus the sum of b, okay? right? So this becomes 1 over n times a sum of xi. Now the sum of b is n times b. Okay. Now if you divide by n, you get a multiplied by 1 over n times the sum of xi, okay, plus nb divided by n is b, okay. So this is equal to a. This guy here is the sample mean of the x's plus b. So you see we have expressed the sample mean of y as a times the sample mean of the x's plus the constant b. All right, the next thing you're asked to show was it's the same thing for the sample variance. So let's start with the sample variance of the y's, which I'm sure you know this formula from some time ago. This is one of the things that we talked about much early on in this course, right? This is the formula for the sample mean of the y's, right? Now, this yi is, we know, is axi plus b, right? And y bar, we just proved that y bar is equal to ax bar plus b, all right? So these two guys cancel out, okay? So what you have is a squared times xi minus x bar squared. A squared is a constant, so you can pull it outside. So this becomes a squared times 1 over n minus 1. Okay. Now this guy here is the sample mean of the x's. So what you have is a squared times this. Right. So this completes part 2 of question 4. Are you guys okay so far? Any questions so far, guys? Please let me know. Hello, guys. Talk to me. Are you okay so far? Hello? Yes or no? Okay, thank you. All right, so let me look at part 3. Part 3 of question 7 is as follows. What you're given is, you're given okay. So you're told that this is 100 times 1 minus alpha confidence interval for mu x, right? Which means the following, that the probability that right is equal to 1 minus alpha, right? Right, this means that, okay, what I'm going to do now is I'm going to multiply everything within the brackets by a. So you get a times lx less than equal to a times mu, this is mu x, less than equal to a times ux is equal to 1 minus alpha. Okay. And the next thing I'm going to do is I'm going to add b to each of these terms. So this is going to be Okay. All right. Okay. Now this guy, we know from part one of question 7, which we just did, right, that this guy is equal to the population mean of y. All right. So what you have is the probability that okay, guys, so this is the same as this. Now, what this implies, what this statement says is that it says that the interval from is a 100 times 1 minus alpha percent confidence interval for mu y. All right. So you see what I've done. So starting from this statement, right, which gives a confidence interval for mu x, the population mean for x, we have arrived into a statement that gives this one, which is the population. This is a statement on the population mean for y. And hence, the confidence interval for the population mean of y is this interval. Okay. All right. So that completes part 3 of question 7. The next thing I'm going to do is the final part. Of question 7. Question 7, part 4. So now here, what you're told is you're told that okay, you're told that let this be a 100 times 1 minus alpha percent confidence interval for sigma x squared, which implies that the probability that is equal to this. Yeah. All right. So this implies that what I'm going to do now is I'm going to multiply everything within the brackets by a squared. Let me know if you cannot see the visualizer clearly. I will try to adjust. Okay, now we know from the first part of this question that this guy here is the population variance for y, all right? Okay. All right, so now what we have here is a statement on the population variance for y. So hence, 100 times 1 minus alpha percent confidence interval for sigma y squared, the population variance of y, is the interval from this to this. All right, guys. Is this clear to, you have questions? Let me know. Hello, guys. Talk to me. Are you okay with this or not? So this completes question 7 in the tutorial sheet. Okay. All right. So let me so we've done question 7. The next question we're going to do is question 6. So here we have a case that where the population mean, and we have a population sigma variance sigma squared, which is unknown, right? And the question, and you have a random sample of 30 of size 30, and the sample mean is 127.442, and the sample variance is this. I mean, if you cannot see this clearly, please look at the PDF file on the course website, okay? And the question is to find a 98% confidence interval for mu and a 98% confidence interval for sigma squared, right? Okay, so if you may recall, I don't know whether you remember what we did about a week ago. There are 4 different confidence intervals I talked about, and these are the ones. This is the confidence interval for population mean when the variance is known. And this is the confidence interval for the population mean when the variance is unknown. And this is the confidence interval for the population variance, and this is the confidence interval for the population proportion. So these are the ones we need to use for this tutorial sheet. So of these 4 different intervals, in order to answer this question here, in order to answer question number 6, right? Because we are assuming that the population variance is not known, right? To find the confidence interval for mu, we need to use this formula, right? Okay. And to find the confidence interval for sigma squared, we need to use this formula, right? So that's what I'm going to do now, okay? So let me show you just a minute. So this is question number 6, right? So to do the first part of the question, the first part is to find the confidence interval for mu, right? So I'm gonna, okay, to find the confidence interval for mu, I'm gonna use this formula, the formula that I just talked about, which is this one, okay? This is the formula I'm gonna use. Now, X bar is given to us in this question, which is 127.442 plus or minus t. N minus 1 is, n is 30, so n minus 1 is 29. 1 minus alpha is 0.02, so 1 minus alpha by 2 is 0.99. S is given to us as S squared is given to us as this. So S is the square root of this. And N is 30, so it's the square root of 30. Right? Now we need to read this. You need to read this guy from the table for the t distribution, which I talked about this in week 8, you may recall, which was last week. So if you read this off the table for the t distribution, which is in the, if you go to the course website, you will see a table for this under the, there's a link in the course website, which is called formulas. So if you go to the link, there's a table for reading this, and you will get a value approximately equal to 2.462. I mean, this guy here is, if you read the table, you will get this, right? And if you simplify things, the lower limit will be 120.64, and the upper limit will be 134.24. So this is the 98% confidence interval for the population mean. Now the second part of the question is asking you for the confidence interval for sigma squared. Yeah, and for that, I'm going to use I'm going to use this formula here, which I talked about last week, right? Okay, so let me write it down. So the formula I'm going to use all right, this is the formula I'm going to use, okay? This is a formula I talked about last week. Now, you may recall that this is part of the formula for the sample variance, that is the numerator here and this one, right? So you can write this as n minus 1 times s squared. S squared is a sample variance. Remember, S squared, the unbiased version has an n minus 1 in the bottom. So when you multiply S squared by n minus 1, you get this, right? Okay. Right, and so this simplifies to, now let's put in the numbers. N minus 1 is 29. S squared is 228.661. And this guy, what you have here is chi-squared with 0. Excuse me, what am I saying? With 29 degree of freedom and 0.99, okay? And this, what you have here is 29 multiplied by 228.661 divided by chi-squared with 29 degree of freedom and 0.01. Right now, once again, to read these two percentiles, you need to go to the tables I talked about last week. And the table gives the percentiles of the chi-square distribution. Now, if you read them off the table in the website, you will see that this guy here, let me write it down, is equal to 49.588. And this guy here, if you read off the table, this will be equal to 14.256, right? Okay, now, so you will get the lower limit will become 133.73 and the upper limit will become 465.15. Okay, so this is the 98% confidence interval for sigma squared, right? So is this clear to you guys? So this completes question number 6, right? Are you okay with this or not? Okay, thank you. Right, okay, so let's go back to the sheet. I'm done with question 6. Now the next question I'm going to do is question number 5. Okay. Question number 5 is question 5 is you have I don't know if you cannot read this, please look at the PDF file on the course website. Okay, so here you're looking at the mean reaction time with the standard deviation, population standard deviation of 0.05, and the question is, what are the numbers that must be taken, or what are the number of measurements that must be taken so that the 95% and the 99% confidence intervals have width not exceeding 0.02, right? So once again, we are looking at this confidence interval, the case where the variance is known, right? Because the question tells you that sigma is the population standard deviation, is equal to 0.05. So we are assuming that the population variance is known. So the formula that we need to use is this one, right? All right, so let me write that down. So the confidence interval for mu is this. Yeah, this is the confidence interval for mu. And the width of the confidence interval is gonna be the difference between the upper limit and the lower limit, right? So which is this is the upper limit, and the lower limit is this one, right? Okay, if you take the difference of these two, right, you will get 2 times this, yeah? Okay, now we know that sigma is 0.05, so let me put that in. Okay, right, so this is gonna be 2 times this is gonna be 0.1 times divided by, alpha by 2 divided by root of n, right? So this is our width, right? And we want the width, we want this width not to exceed, we want the width not to exceed 0.02. In other words, it must be less than or equal to 0.02, right? So this implies that root of n, right, root of n must be greater than or equal to right? And this implies that root of n still must be this guy here is equal to 5, right, times this, right? And excuse me. And if you take the square both sides, then you have n greater than or equal to 25 times multiplied by this, okay? Are you guys with me so far? Okay. So now what we need to do in order to answer the question, we are looking for 95% and 99% confidence interval. So there are 2 cases we need to consider. So the first is where the 100 times 1 minus alpha is equal to 95, which implies that alpha must be 0.05, right? Which implies that z 1 minus alpha by 2, if you read this off the table for the normal distribution, right, this is equal to 1.96, right? So if you call this, say, star, let me call, just for the sake of notation, let me call this star. So star implies, from star, we can see that n must be greater than or equal to 25, right, times 1.96 squared, right? And if you work this out, this would be approximately 96.04, right? So in other words, n must be greater than or equal to 97, all right? Okay, so that's the first part of question 5. To do the second part, we take 99%, right? Are you guys okay with this so far or no? To do the second part, guys, I'm gonna take 100 times 1 minus alpha to be 99%, right? So which implies that alpha must be 0.01, okay? So your z 1 minus alpha by 2 will be, if you read this off the table, for the normal distribution, this will be 2.58, right? So once again, use from star, this is star, by the way, this equation here, from star is n must be greater than or equal to 25 times 2.58 squared, right? And this, if you work this out, this will be 166.41, right? So in other words, n must be, n must be an integer. So this is the same as saying that n is greater than or equal to 167. Okay, guys, so this completes part 2 and also completes question number 5. Is this clear to all of you or not? If it's not clear, please let me know. I will go through again. Hello, guys, talk to me. Are you okay with this? You sure? Okay. Okay, thank you. So we've done question number 5. The next question I'm going to do is, so let me go back. So we've done 5. The next question is question 4. So in this question, we have a random sample from a normal where sigma squared is known. And the question is, what is the confidence interval for mu and what is the width? Okay, let's see. So this shouldn't be difficult to do. So question, right. So this is question number 4, guys, okay? So clearly, if sigma squared is known, right, then the confidence interval for mu is this one. This is, we are looking for the confidence interval for the population mean, which is this. This is the one when sigma squared, the variance is known, right? Okay. So the answer is the confidence interval for mu is this one, right? This is the confidence interval, right? Now the width of the confidence interval, as I explained before, the width is the difference between the upper limit and the lower limit, right? So it is, the upper limit is this one, right? And the lower limit is this one, all right? So if you take the difference between these two guys, you will get the width to be equal to all right, so this is the formula for the width, right? Okay, all right, guys. Now the question is also asking you what happens to the width with respect to each of the following things, right? So what happens to the width with respect to alpha, with respect to sigma, and with respect to n, Right, let's take alpha first. As alpha increases, are you familiar with this notation, guys, in mathematics? This means that as alpha increases, yeah, z1 minus alpha by 2 will decrease, right? All right. So the width will also decrease. Okay. Do you see what I'm saying? As alpha increases, this quantity here decreases. So the width is, remember, the width is 2 times this times this. If this decreases, the whole width will decrease, right? Now, with respect to sigma, as sigma increases, because you have sigma in the numerator of this expression, the width will also increase. Okay. And finally, as n increases, as n is in the denominator of this expression, right? So as n increases, the width will decrease. All right, because it's in the bottom, it's in the denominator of the expression. So as n gets larger and larger and larger, the value of this will get smaller and smaller and smaller, right? So are you guys okay with this? Hello, talk to me, guys. Are you okay? Yeah. If it's not okay, let me tell me. I'm happy to go over again, right? Okay. The next part of question 4 is asking you to tabulate values of this width, right, for different values of n and alpha, right? And if you read the question, it says to consider the following values for n equal to 5, n equal to 15, n equal to 30, n equal to 50, and n equal to 100. So these are the different values for n you are asked to consider, and you're also asked to consider alpha 0.1 and alpha equal to 0.01. Okay. Okay. So okay. Now for each combination of alpha and n, you can work out what this is, right? Okay, and we are taking sigma. I think sigma is taken to be, if you read the question, it says take sigma to be 10. So we are taking sigma to be equal to 10 in this expression, right? For sigma 10 and alpha and n given by these combinations, right? You will get the following values. So when alpha is 0.1 and n is 5, the width will become 14.71. When alpha is 0.1 and n is 15, you get this, and so on. Okay. All right, so these are the values you will get for this expression, right? When sigma is 10 and n and alpha are given by one of these, right? Okay. All right, the next thing you are asked to do is the following. You are asked to plot, which I have already done. I don't know if you can see this, right? Maybe you can see it now, or maybe not, I don't know. So I'm sorry, because of the lightning, it's very difficult to see. Now what I have drawn here, guys, is the width on the y-axis, and on the x-axis I have drawn n. And as you can see, the width decreases with increasing values of n, right? Okay, the width decreases with increasing values of n. And there are two different curves. There's one of these curves is for alpha equal to 0.1, and the other curve is for alpha equal to 0.01. So the main feature that you see, is that the width, the magnitude of the width, I mean, the width is positive anyway, so the width decreases as n, the sample size decreases, right? So that completes question 4, unless you have questions. Are you okay with this? Or hello, guys, talk to me. Are you okay with question 4? Or you want to ask me some questions? Come on. Are you okay with this? Sure. Okay, thank you. All right, so the next question I'm going to do is question 3. I don't know if you can read it. It says, let me hold it closer to the camera. It says that in random samples of 50 households, 80 were found to have 3 or more TV sets. Find an approximate 90% confidence interval for the proportion of all households having 3 or more TV sets. Right, okay, so in this case, we are talking about proportions. So the formula that you need to use of these 4 different formulas, the one you need to use is clearly the last one, right? Okay, the last formula is the one that corresponds to proportions, which is this one, right? So I'm gonna use that now, okay? So this is question number 3. To see, oh, sorry. Hello, guys. Are you? I don't know what the problem is. I think it's. Let me try to refocus the camera. Just a minute. Okay, I think this is the best I can do. Maybe you can see it more clearly if I bring it closer. Okay. So the formula that I'm going to use here is the following: that x bar excuse me, is x bar plus or minus, excuse me, I think it's playing once. It's this one, right? Okay, all right. Hopefully you can see this better, I don't know. So in this case, the formula, you're told that, if you read the question, it says that n is equal to 500, right? X bar is the sample proportion, which is 80 divided by 500, which is 0.16. And we are looking for the 90% confidence interval, which means that 100 times 1 minus alpha is 90. So your alpha is 0.1. Okay. So your z 1 minus alpha by 2, all right, is gonna be equal to 1.645. Okay. Now let me put this in the box. Now subbing this into the formula. This is the formula, right? You will get the following. You will get 0.16, right? Excuse me, once again, it's a problem with the camera. 0.16 plus or minus 1.645 in bracket, in a square root 0.16 times 1 minus 0.16 divided by 500, right? Okay, and if you work this out, you will get the lower limit to be 0.133 and the upper limits to be 0.187. All right, so this is the, hopefully this is better. So this is the confidence interval, the 90% confidence interval for the proportion of households who have 3 or more television sets. Okay. All right, so this completes question 3. Are you have questions on this or no? If you have, please feel free. So I used this formula here. This is the formula for the population proportion. So it's just a matter of putting in the numbers into this formula, and this is the interval that you will get for the 90% confidence interval. Okay. Are you guys okay or no? Hello, talk to me. Hello, guys. Okay, thank you. All right, so that completes question 3. The next question I'm going to look at is the next question is question 2. Question 2 is I don't think I run out of time. Okay, I think I will. I have run out of time to do question 1 and 2. I will post the solutions to the first 2 questions and all the 7 questions on the course website on Thursday of this week. So there will be 3 types of solutions. There will be the typed solutions, there will be the handwritten solutions, and there will also be a detailed video solution for all 7 questions. Okay, you will see them on the course website on Thursday of this week. All right, guys. So have a great evening wherever you are, and take care of yourself. And if you have any questions about this course or anything related, please feel free to contact me 24/7. Okay, by email, Skype, Zoom, or phone. My phone number, I'm sure you know, is 0161-273-2941. All right, guys, take care. Bye. Take care and keep safe.